I think we came in and really put a pretty ambitious vision together. I'm kind of humbled to say that a lot of it's come true. The key for us was being as open and transparent and collaborative as possible. That sounds very simple to say, but it's not easy in practice. Also, just elevating everything that's happening in the community as well. I've always seen PyTorch as a platform in all ways.
Welcome to another episode of Together Talks, a series of conversations with researchers and industry leaders about generative AI, brought to you by Together AI. I'm Percy Liang, co-founder of Together AI, and today we have a special guest, Joe Spisak. Joe is a leading figure in AI and machine learning. He is currently the director of product management for Gen AI and instrumental at building Llama at Meta. Joe also previously spearheaded the growth of PyTorch, co-founding the PyTorch Foundation. He has led key roles at Intel and AWS, and also founded the AI for Math and Science pillar at Facebook AI Research, leading groundbreaking work in protein folding, AI-guided material discovery, and theorem proving. Welcome, Joe.
Thanks. Great to be here.
So, Joe, we've chatted a lot in the last few years, and usually it's about the next release or something about the future, but let's take a step back in time and think about where we've been. So there's two things that I think we're both passionate about, open source and AI. So let's start with open source. So I still remember I first got into open source through Linux. It was sort of amazing to me that you had this piece of software, it was free, and you could look at the source code, you could modify it, and it was very liberating and empowering in a way. So I'm kind of curious. Obviously, you've had a long history with open source and develop instrumental and bring PyTorch to tons of people. So what's your journey through open source? When did you first kind of get into it, and what excites you about it?
Yeah, it's something I've worked on for a long time, and it's honestly I really enjoy our conversations. And I think the last one that was stuck out of my mind, by the way, is the one last year when I was late to my own talk at Ray Summit when we were talking. But I think for me, a little bit of kind of background on me. So I actually started my career in semiconductor, and so out of school I was electrical engineering. I was a VLSI designer. I did product engineering. I did development basically of mobile SoCs that went into Motorola phones. And I found my niche in video compression. So one of the first chips I designed was an encoder for essentially FaceTime video. I'm not going to say the year because it's going to date me, but a while ago. And it was one of the first phones that actually did two-way video. And it was really cool. I really enjoyed it. I loved working in that space. It was deeply technical, on the bleeding edge of things, but it was a very kind of closed environment. And so I spent well over kind of a decade in that space. I had just exited a kind of an internal, a homegrown startup out of Intel into Facebook, actually doing video transcoding in the cloud. And I was kind of looking for something to do. And I got invited to a retreat at Berkeley. I met Yanqing. I met Trevor Darrell for the first time. And I was in this room, I remember, surrounded by ostensibly some of the most competitive companies in the world, right? You had Yahoo was there, and Google, and
You're
Facebook.
dating yourself.
And I am dating myself, right? and I'm just in this room, and NVIDIA's there, Intel's there, and everyone's kind of working on this project. I'm like, what is this really cool project? And I mean, obviously I'd played with Cafe and that, but it was amazing how open and collaborative it was, and people were publishing papers together, and it was just a stark contrast from working in the compression space where you had MPEG-LA and you had patent pools, and IP was treated as just this thing that you had to protect and fight and fight for, and tooth and nail, and so it was just this breath of fresh air, and from there I was hooked, right? I went all in. I was self-taught in machine learning. I took Andrew Regg's course on Coursera in machine learning. I was coding at night and using Cafe and other open source projects out of academia, and it's just that's really how I started. And so a lot of it was kind of happenstance, and just honestly, the people I met were so passionate, and a lot of them are still friends today, which is pretty amazing.
Yeah. Yeah, I mean, I think the open source community is just amazing. And I think open source also connects a lot with open science. So I'm coming from a kind of academic background, and that's what everything is you do is you publish, you put things in the open. I think there's kind of a strong connection between the roots of open source and kind of academic science. So it's great to see that this is kind of becoming also more mainstream. So now let's turn to the other thing that's of interest, which is AI. And of course, AI has been around for a while, but it looks very different now than even 6 months ago, a year ago, 5 years ago. And as you mentioned, you sort of got into machine learning, self-taught. Kind of from your perspective, how has AI developed, and what is kind of exciting about AI for you?
I mean, I think it's kind of like if you look at the last decade, which is kind of where I've been in AI, and we didn't call it AI, we called it deep learning, and there was this whole argument over machine learning versus deep learning, if you recall, and all of that. Because I started out looking at CNNs or convolutional neural nets, and that was like contrasted with things like k-means and regression and so on in the big data world at the time. And so I started out mainly looking at deep learning, I would say, and like the first thing I think, like, it's probably been like 10 years since I've done this, but I scaled up a net. It was a CNN. It was an AlexNet, actually, on 128 dual socket Xeons, right? And I wrote a CloudFormation template on AWS to orchestrate the servers, and it didn't actually have fault tolerance. So like every so often a node would go down, or whatever, it was a slow node or whatever, it would fail. But it was like, it was cool, and I thought I was like training at scale at that time, right? So I think like the paradigms are largely similar to where they are today. It's just like the numbers are way different. I mean, if you look at like Llama 3, we trained on 16,000 H100s, which is just like orders and orders of magnitude, like bigger in terms of compute and size of cluster. And now, with like Llama 4, we're looking at even bigger, and 5, 6 plus times that, maybe more. And it's the scale just is like unrecognizable compared to like 10 years ago. But the ideas are the same. Like same with like model zoos. Like Cafe had their model zoo, and there was this paradigm of transfer learning. Take a convolutional net or an LSTM or something like that, be able to fine tune it, or do transfer learning as they call it, back then, and like and be able to like take that and adapt for your application. Fast forward like 10 years, and Hugging Face has hundreds of thousands of models of derivatives, and people are fine tuning these models and putting them out there, and so like they were, the team at Berkeley was definitely ahead of their time when it came to that kind of stuff.
Yeah. I mean, a lot of these ideas are old. Stochastic gradient descent has been around for since the 50s, but every decade with more data and compute, I think things change really qualitatively. So let's talk about PyTorch a little bit more. So PyTorch is just amazing. So when I was a kid or in grad school, these tools didn't exist. Right? You had to implement your own gradients, and you often get them wrong. You debug them. It was a big pain in the butt. And now kids have it easy, right? They define their model. Actually, kids have it really easy because they just prompt it. But kids, like, let's say five years ago, also had it easy. They I think PyTorch does a lot to alleviate the user of all these infrastructural and kind of messy details and allow them to focus on the problem and the modeling. So I think that's great. So maybe you could tell us a little bit more about your kind of journey through PyTorch and what was your kind of vision for it when you were leading it?
Yeah, it's I met Sumit a long time ago, probably 8, 9 years ago. I think I was at Intel at the time. I remember I was presenting some of our strong scaling results that we had out of Intel Labs, and I remember he just tore me a new one in the discussion. It was like fantastic, and he called me afterwards, and he's like, there was nothing against you. It was like I had a bunch of questions around the some of the work in terms of weak versus strong scaling, and like the quality of the code and a bunch of things, right? And I was like, okay, I like this guy. He's okay. And we kind of became friends from there. And I was invited to a workshop it was an ICML workshop in New York. I remember where he was presenting, and him and Adam Pashka were presenting there, and that was right around the time where they were trying to decide whether or not to move to Python. Obviously, like in hindsight, it was like, duh, of course you're going to move to Python, right? The world is Python. There's such a broad ecosystem. And we,
Do you know what saying Lua?
Said Lua, oh my God. Or some of these other, yeah. So I think like in hindsight, it was such a great decision. It was in retrospect obvious. But I think at the time, like there was obviously other opinions. Fast forward like a couple of years in 2017, they were really looking for like a product leader to come and help build a bridge between PyTorch and Cafe 2, and that's when I joined Jianqing, and I joined Sumit, who I had still had stayed in touch with and become good friends with both. And I think we came in and really put a pretty ambitious vision together, and I was like really humbled to be part of that, and working with Shrep, our CTO at the time, Yanqing and Sumit and Lin, who's over at Fireworks, and really put this ambitious research to production vision together. And I think I'm kind of humbled to say that a lot of it's come true, right? When we came about the vision, we didn't think about like we got to go like beat the other framework or beat whatever. It was very much, we took a kind of user-centric approach. We took a very researcher-centric approach. Like when it came to like new features or when we were building things, we had this really tight feedback loop. I remember like, Andre Karpathy in the early days would be like on Slack or on Google Plus, whatever, in the early days. And he'd be like providing like real-time feedback, and like people would be landing, diffs and basically within hours, like providing, some test wheels for him to go and play with. And it was just like such a tight feedback loop with like folks like him and Jeremy Howard, and who are still obviously big proponents of the project today. And I think that resonated a lot, and it built this kind of like core community of like rabid fans of it and rabid users. And we didn't, so obviously the opposite strategy could have been, we build this thing, like we go try and sell it to the world.
Yeah. Like
a lot of other kind of tools or folks do. We wanted to have really a grassroots approach to it. And that's it. And I think what really, I would say, vindicated our strategy was when we had like Google come to us and say like, we got to collaborate on this.
Yeah.
And you started having Google have a team, build up on their side to work on PyTorch. And you're like, oh my God, this is wild.
Yeah.
Or you have collaborations with Apple and OpenAI and folks, and we helped. Myself and Sumit worked with Tom Brown and folks over there for them to go all in on PyTorch several years ago, and that was a huge moment for us.
Yeah.
And really important. So.
Yeah. I mean, I think the research-centric focus really shows. I remember when it first came out, all my students were like, okay, ditch TensorFlow, go to PyTorch.
Yep.
So PyTorch, obviously started at Meta. And I don't know how many people realize, but in 2022, you founded the PyTorch Foundation, which is under the Linux Foundation.
Yep.
So can you say a bit more about what's the significance of that? Is that sort of like a graduation ceremony of sort?
Yeah.
Or how do we interpret, and what are the implications for PyTorch going forward?
Yeah, so the project, what was interesting, there's not a lot of folks really know this if you're not kind of in the code, but PyTorch itself was, the source of truth for PyTorch originally was in GitHub. And then when we merged, the Cafe 2 and PyTorch teams together, and we had one code base and really did a lot of refactoring over, I would say, a year, maybe two. We actually took the code base and brought it into Facebook inside the company, essentially. And so if you were like a contributor to the project, you basically would put up a pull request. There would be this thing that you couldn't control that was called Fabricator, and you'd have to if you were a Facebook or a Meta employee, you would import it into Fabricator, and it would run some internal tests inside the company. And the weird thing is, like, it would be running tests on completely different code bases, like for our ads infrastructure or things, and you get a test failure, and you're like, what the hell just happened here? This has nothing to do with PyTorch. And so our vision all along was to have kind of distributed ownership of the project.
Right.
And I would say we like overcompensated for the fact that our code base wasn't in GitHub by just like overly working with different community members. We had there was a persons of interest doc on PyTorch.org that I maintained that showed basically different modules within the code base of who owned what, who's maintaining what. I mean, we had Peter JC123 in China who was managing our Windows builds for the longest time. I don't think I've ever met him. I'd worked with him for years. And we had this kind of distributed ownership of these different projects. Like Microsoft was helping with Windows, Intel was working on, so we had independent developers owning different parts of it. We had someone at NVIDIA, someone at Twitter. So we had this like really distributed, but the challenge was we really couldn't give commit rights to anyone because at the end of the day, you had to have a Facebook employee, kind of manage the PR and do the life cycle and land it. And so, we thought through, like, this was something we've been thinking about a long time. Like, how do we get this into a place where we have a truly sustainable ecosystem? Like, we've overcompensated myself, Sumit, and a lot of others to make sure that the project maintained a community feel. Like that was, you have no idea how hard we as a big company to do that. But we wanted it to really be organic. And that's when we actually, number one, moved the code back out to GitHub, which was a ton of engineering work, a lot, way more than you'd expect. And then number two, we thought about, what is it to be sustainable long-term? If I'm a company and I want to take a dependency on PyTorch, how do we give them the comfort that they can do that it's not just kind of Meta's thing and they take their toys and go home at some point. Like, we didn't want that. That was never going to happen, but we didn't want the perception of that possibly happening. And I think we wanted more voices more officially, because a lot of times we were kind of the mediator of a lot of the ecosystem. We bring together Google and Microsoft and Amazon and startups and independent developers, and we were kind of like this hub with so many spokes. But we started really to become this bottleneck, I would say, and we couldn't manage it all, and we really wanted to scale it up. And that's where the foundation idea came. A lot of discussions, a lot of doc writing, a lot of leadership reviews, and then you fast forward and we brought it out there. So
that's amazing. I mean, I think it makes a lot of sense. On the community front, obviously PyTorch has an incredible community, and in general, open source benefits a lot from having a broad community of contributors. At the same time, a lot of projects, not just open source, have a heavy head where there's a few people who do a ton of work, and then there's a long tail. And so, can you say a little bit more about the dynamic between the main people who are actually full-time working on PyTorch versus the contributors and the value that each provides to the whole project?
Yeah, I mean, there's definitely a set of core maintainers. So, our governance is on pytorch.org. You can look through it and you can understand, like, what it takes to become a committer on the project and a maintainer. And obviously we have a great BDFL in Sumit, and he has such strong technical vision. And in that, I think the key for us was, I think, being as open and transparent and collaborative as possible. I think that sounds very simple to say, but it's not easy in practice. I think the other piece of it is, when we thought about components of the project, how do we kind of create those in a way that doesn't what we call king make? So whenever we were creating any new piece of the project, maybe it's a library, maybe it's a library on Vision, maybe it's from mobile, something that is like adjacent, kind of an ecosystem or a component around the project, even a component within the project. But we thought long and hard about, like, what does the state of the current world look like? Who's developing what? How to be sensitive to the rest of the community and what they're developing before we would move forward and actually call something PyTorch, because there's implications to that. And we actually felt this very early on in the project when we announced 1.0, and we had this at one point. Our marketing team had this really heavy-handed branding approach, and we released, I think, what was called like Facebook language or Facebook NLP library and on PyTorch, and it was like we had such blowback from the open NMT community. It was incredible. It was like swift and fierce, right? And so we pushed back internally and said, like, we can't do this. Like, this is such an important part of the community. We want them to feel like they're part of it, and we're not there to kind of, compete with them. And so we've carried that principle over the years, and it's served us well. And I think also just elevating everything that's happening in the community as well. So I kind of I've always seen PyTorch as a platform in all ways. It's obviously a platform as a developer, and I can build and train new models and develop AI. but we're also building APIs such that others can build on top of us.
Yeah.
So when like DeepSpeed comes out and they're building like new paradigms for like large scale distributed training, trillion scale parameter, MOEs, whatever they're doing, like some would say like, is that threatening to your like distributed training like APIs? No, they built on us.
Yeah.
It's just extending us and actually like building components in a way such that it reaches, new audiences or, same with quantization. Like our quantization APIs are very low level. And so I remember like Will Falcon and the team over at Lightning, they built abstractions on top and it made it way easier to quantize.
Yeah.
And I was like, thank you. This is great. Because like our APIs are super low level. So if you want to do like deep researchy stuff, you can. But for like the common average user, like it's way too low level in a lot of ways.
Yeah.
So
that's
where the community comes in, right?
Power of open source.
Exactly.
That you can build on top. Yeah. So let's switch gears a little bit and talk about AI.
Sure.
So in particular, one of the most exciting things, in my opinion, that happened this year is the release of Llama 3. And before that, my students would try these like fancy agent based tasks, and for open models, they would just never work. And so I was really excited, and I told them when Llama 3 comes out, you got to try it because it has open weight models have the benefits of reproducibility. You don't have to worry about some API getting deprecated and so on. So thank you. That was wonderful. But I guess from your perspective, you've seen a lot of uptake of Llama 3, I'm sure.
Yep.
What are some of the most favorite things that you've seen people do with it?
I'm to date, I'm so surprised. Like some of the, I have startups that come to me. Some of them are stealthy. That they come and they say like, we just couldn't afford to do what we're doing without you. These are like coding copilots. There's education. Companies and University of Peoples, for example, is part of our Llama grants program or our Llama ecosystem, and they use it. They have students globally speaking literally hundreds of languages, and being able to basically fine tune a model of that caliber and be able to deploy it and support kind of their global population of students. I personally love to hang out on like the local Llama community. Yeah, maybe I don't know what it is, but I love to see what people are doing. I think the personal assistant and local agent like space is super fun, because people find new ways to use these things and they're running them on their Macs. And we just released, obviously, the small models we'll talk about, a few weeks ago. And so you can build your kind of personal agents like on your phone. And we actually have a full mobile app that you can copy paste and fine tune and so on. So I think I'm just continually surprised at the applications. And I remember I was talking just a few weeks ago. We had I won't name which government, but one of the major Asian governments who's investing a lot in AI. They visited us in Menlo Park, and they're building anything from like how their employees are making mid-career changes. There's an agent that helps them navigate that process. They've also built a legal agent that helps accelerate legal reviews and contract reviews, and which is obviously one of the thornier projects or thornier domains to like build generative AI on. Yeah. And I'm just I'm amazed. I think they're finding ways to take a non-deterministic system and make it as like asymptotic to a deterministic system. So I see like the applications are broad. I also get pretty excited when folks like GGML, like the GGUF quantization format, within an hour of our weights getting released a few weeks ago, they had weights already on Hugging Face. Like, oh my God, are you kidding me? Do you not sleep in Bulgaria? Like,
it's amazing when Llama 3 came out, the rush of all the people trying to put out the fine tunes, the quantized models, hosting inference.
People were running on an iPhone that day. And this is like an 8 billion parameter model. I'm like, okay, we've got to get small models out there. People are going to love them.
Yeah, that's great. The other thing that I think a lot of people wonder about is you're spending hundreds of millions, if not billions of dollars training these models, and you're just giving it away for free. Isn't that kind of insane? So what do you say to that? Is there a way to kind of think about how this makes sense for Meta?
It's definitely a lot of money. It's definitely, and the stakes are getting higher. I mean, I think to train Llama 3 was very expensive. It was 16,000 GPUs for several months. And you can, for those, at home, you can kind of run your numbers and you can kind of estimate even what the pre-training costs, were. And then there's post-training and there's red teaming and there's human evals and, SFT, annotation data, all that. So it is very expensive to develop and do pre-training in the space. It's quickly and more becoming kind of a reserved set of companies that are able to kind of spend that. And yeah, for us to give away for free and at that scale is unprecedented. But I think like if you read Mark's note, around the Llama 3 launch or Llama 3.1 launch, I think it's really important for us. It's kind of like if you've hung out with Facebook or Meta for any given time, like you realize how important open source is to the company. It's over a decade of open source, 1,000 projects. FAIR feels very much like an academic lab in a lot of ways. So open source is kind of built into the DNA. And I think it was important for us for the ecosystem to not grow up around a kind of closed paradigm. And so for us, it's like we feel like it's important for us to continue to cultivate the open ecosystem so that we ourselves even don't get kind of, if everything kind of rallies around or kind of converges around a closed paradigm, like we ourselves aren't kind of in the future potentially held hostage by a closed environment. So we're gonna bear that torch and we're gonna continue to release not only models obviously in the like full stack, PyTorch, all the components, agentic, and we're gonna seed innovation. And I think it's like something that maybe Meta has done historically in the past for a lot of things, but obviously the investment level continues to increase, and we're one of the few companies that is kind of able to, we have a core business, it's doing well, we can afford it,
yeah.
But it's strategic also for us, right?
Yeah.
So we're going to continue to do it, and I think it's really important.
Well, it's great that incentives align.
Yeah.
I think one of the amazing things that you can do once you have weights is, as a researcher, you can kind of do a lot of research and inspect them, look at layers and understand what's happening, fine-tune, quantize, and all that you couldn't do if you only had just API access. So I think that's really exciting. One of the things that people do say is, it's the double-edged sword of, well, people can do whatever they want with the models.
Yep.
And we've seen, over the last year, from some, parties, concerns about risks of AI. So the fact that you have models, they can, pick your favorite one, disinformation, cyber attacks, biorisk, and so on. And the idea is that, well, if you put these models into the open, then there's no controls on what people can do.
Yep.
So how do you guys think about those risks, and are there ways to mitigate them?
Yeah, I mean, this is obviously it's a hot topic. It's I'm actually after being in the space for such a long time, I guess I was happy that responsible AI was surfaced again. Really, is an important area. That was
now it's called AI safety, though.
AI safety, right? I mean, we talked about responsible AI, and it was a for the community, it was largely, I don't want to speak for the whole community, but it was kind of an afterthought for many. It was like it wasn't as important of a topic, and I think obviously Gen AI has surfaced AI safety again, and we talk about CBRNE and these kind of risks, and so I mean, I think this is where we invest a ton. I mean, we invest in every step of the way in terms of the model development, deployment. So from from pre-training data to SFT to red teaming to human evals to something that we started last year with really system level safety. So there was a project called Purple Llama that I helped found last year, and I think one of the things that was really important to us is that safety is one of those things where it just makes sense to work in the open, because if you look at the different types of harms, I don't know. So I'm actually interested to get your take here. So I see evals as like the analogy that I use for evals is like you're in this pitch black room and you have a flashlight, and that eval is like it's a flashlight, right? And you can kind of point it at something, and you can get some signal depending on what that eval is, but the rest of the room remains like pretty much pitch black. And so you need as many of these flashlights as possible to understand like the true corner cases and things that your models can do or can't do, or the risks and the things that they may present. And I look at, for example, like academia as just a treasure trove of knowledge and data and expertise. Like we don't have bioweapon experts, for example, at Meta, that I know of anyway. We don't have explosive experts, right? I don't know. And this is one of the reasons why we're investing in AI Alliance. Is we have over 100 members. A lot of them they're startups, they're not-for-profits, they're academia, they're industry. Like, how do we bring these folks together with a diverse set of perspectives? And one of the things we're trying to do is actually start to stand up these bring your own evals, and we can help people build these evals for all of these different domains, and make those available to anyone, and start to understand like how these models are performing on a lot of the areas that we're just not looking at today, because we just don't have a way to kind of understand the risks. So what the strategy that I took really at Meta is to kind of seed the ecosystem, like provide, again, going back to the platform analogy of like, how do I provide these platforms, these tools that others can build on, whether that be like our cybersecurity evaluations, which we use internally, to like our Llama guards, which they themselves can be fine-tuned for a broader taxonomy, and you can like extend that for your application. We released one just a few weeks ago that's 500 megs. It'll run on your mobile device. I don't know why I'm pointing at my coffee mug, but it'll run. It's very small. It's a pruned and quantized 1B that is very, very fast, and it gets actually orchestrated with a model that's on device as well.
Oh, cool.
And it runs 50, 60 tokens a second, and it's fantastic. But how do you provide those kind of things such that others then can build on those? And we've taken this to ML Commons and started to define these taxonomies. So I do think like safety is one of those things where, yes, we can do a bunch of stuff at the model level, but we also need to think about it more holistically, and we need to also bring in an open community, because we can try and solve it. We can work with academics like yourself, or we work with together as well, deploy Llama Guard.
Right.
But you're right. I think that like malicious actors are going to do what they're going to do. And ultimately, we believe the positives outweigh the negatives.
At least we know from computer security that security by obscurity doesn't really work that well.
That's right.
And having the transparency and everyone staring at this and finding defects in the model is I think a healthy dynamic. The other thing I mentioned Llama Guard, which I think is great, is that we need to step up our defenses. Just like we have email as a dual-use technology. You can send spam, you can send useful things, and we've had this whole ecosystem of developing spam filters. And I see things like Llama Guard, and probably we need more than that.
And Prompt Guard for prompt injection.
Right.
So again, you can extend that as well.
Right. So these tools, I think, can help us because I think these models are going to get better and cheaper, and I think holding things back things are gonna kind of leak out in some sense. The other thing I think we mentioned is cybersecurity that I found interesting. So we've been doing some cybersecurity evaluations, and initially we came from a kind of a pure AI risk perspective. But we collaborated with Dan Bonnet, a cybersecurity expert, and he's really interested in from a penetration testing. He thinks this is like an amazing tool to improve the cybersecurity. So it's actually kind of interesting how things, depending on how you look at them, have different kind of implications. So continuing talking about sort of these applications on top of models, right? When we think of the typical applications, people think of chatbots, essentially like ChatGPT, which has kind of set a standard for what a Gen AI application looks like. But foundation models are much more of a kind of general purpose technology, and I think we've seen also a lot of movement in other domains, such as biology or sustainability and other areas. Any place where you have a ton of data that you can kind of feed into a large model, I think is an area maybe where there's room for some pretty big step changes. So a few years ago, you founded AI for Math and Science at Facebook AI Research, and I'm wondering if you could talk a bit more about the applications that you explored then. I think protein folding in particular, but others as well.
Yeah, we're quite proud of that pillar that we created, that org. So myself and Lawrence Vander Martens, who I work with, obviously still is in Gen AI at Meta. I think we got excited about anywhere where the kind of like the kind of in silico computational world would meet the physical world. And I'm actually quite also proud to say, like, a lot of those teams have kind of graduated to do other things, right? The Mistral team was our theorem proving team, which is really cool, and trying to solve AI in mathematics. The protein team has since spun out and created evolutionary scale AI, and the open chemistry team is actually still going and they actually have multiple projects, and so, like, I think anywhere where you have like this kind of computational world meets real world. So in protein, obviously, like, you ask an ML researcher, like, what's a wet lab? They're like, I don't know what the hell you're talking about, right? What is that? And so, at some point you can generate proteins, like, with your model, but like ultimately, like, how do you then, validate or crystallize those, and then, validate those in an actual, like, wet lab that you can actually, validate the functionality of the protein. And so we would work, for example, with like David Baker at UW, and he had a wet lab obviously up there, and we also had a cloud lab that we worked with. Same with the open chemistry, where we had the project was really founded on trying to find new materials for catalysis. So we were looking at materials beyond like platinum and palladium, finding cheap materials to accelerate the generation of things like green hydrogen. And how do you then take all of when you're doing essentially like molecular, like you're searching through molecules, right? And you're trying to find molecules that align with certain properties, and you have billions of these molecules, and you're basically an approximation of Schrodinger's equations, DFT, and then your AI or your model is actually approximating DFT, right? And trying to drive, because inference, if you can drive inference costs down, you can search much faster in the space. And what was super fun about those projects is not only the partnerships, but we would, for open chemistry, that team, again, like Larry Zitnik and the team, they basically would use offline compute in our data centers to generate data and then open source it.
Yeah, nice.
Which was so cool. So you had, when you're not on Facebook, for the record, I don't use Facebook, but that's beside the point. For the folks that are on Facebook, when you're not on Facebook, there are servers that are, not doing much. They're fairly idle. And there's an internal tool that basically allows you to just use that compute. And so we generate that and we'd open source it. We train models on it.
That's cool. Might as well, right?
Might as well, right? It's great use of infrastructure, and it's renewable and so on. And that actually has spawned a number of projects. Like, number one, we used that same paradigm for our own material search for our glasses. So if you saw the Orion glasses, some of the materials were just fundamentally first principles, new materials we had to discover. We have a whole material science team at Meta that does that. And I didn't even know that until we started working together a couple of years ago. We also have a partnership with Georgia Tech, and how we're using that same paradigm again, but in a different kind of material regime, looking at sorbents for things like direct air capture. So how do I develop a sorbent, for example, that is like within a temperature, a regeneration temperature that isn't, like 800 degrees or 700 degrees, something that actually may generate more carbon than it's actually going to capture, right? And so there's a project going again with Georgia Tech, and we open sourced a lot of data and models earlier this year for that Open DAC project. So for me, like, I think these are like some of the best problems to go after. Yeah. Because they're not chatbots. They're not.
I mean, I think it's really exciting what you can do. Right? I'm kind of curious what has to happen, kind of from a research or technology perspective. So I see kind of there's the general purpose language models, which can do a lot of high-level planning and reasoning and all of that. And then there's these models which are trained on domain-specific data, like proteins. And I feel like some combination of that should allow you to kind of if you are able to put those things together, now you have really kind of super intelligent abilities.
You can imagine LLM, instead of generating, an autoregressive set of text output, it's generating, a sequence, protein sequence, and it's I think, I mean, Alex Reeves and the team at ESM or Evolutionary Scale are just like, to me, on the leading edge of this, and I've seen their work, and by the way, they open source everything too, which is so cool, right?
That's awesome.
It's used by biotechs and pharma companies to do drug discovery and which is incredible. And we've seen this in our partnerships while I was there. Can't name the partners, but like I've seen how this work is leveraged in that world, and it's truly like inspiring. But I think like one thing that I've definitely observed is like it's these, like the technology is there and the tools are there, but there's also like this cultural, almost like behavioral thing that bringing these communities together, because they're very different. The tools they use are different. Like, people don't use PyTorch in like the pharma space, right? At least on or in the computational like biospace, or in the material space. And so like bringing these communities together is like different simulation environments and like AI tools. It almost becomes like you're just bridging like these worlds, and it's more of like getting people to just talk, and to me, like open source becomes a bridge for a lot of this, right? It goes from like proprietary tools, closed, siloed environments to like, okay, we are working in the open on common tools, and those people who kind of have deep expertise in like both domains, like ML, but also say in like computational biology or computational chemistry, like they are the ones that can sit there and actually like bridge between these communities. I actually think that's like the hardest part of all of it. The problems are like reasonably tractable. It's really bridging the communities. It's from my experience anyway.
Yeah, and open source kind of facilitates.
It does.
That.
It totally does.
Yeah. I wanted to go back to something that we alluded to earlier, which is models on device versus large. So we were kind of seeing a few trends here. One is that the models are getting scaled up. They're kind of going to have more and more compute, more parameters. And that's one trend. And on the other hand, in the last year or so, we've seen incredibly powerful small models that you can run on device. And what do you see kind of is to be the kind of the interaction? Are both kind of going to continue as parallel tracks, and we'll have experiences where you'll use both essentially, or are things going to change in some other way?
Yeah, this is one of the reasons, honestly, I was very excited that we released the 405B, and number two, we changed our licensing such that you could use the outputs to do anything you want.
Yeah, thank you.
That was a long discussion, a lot of internal back. I think we were very, very happy when we were able to change that, and that excited a lot of the community. So I do think like there's going to be the large model and there's going to be the small model, and they're going to interact and they're going to be orchestrated together. I think it's funny because there's clear use cases for like a big model calling a small model, and then there's clear cases for a small model calling a big model. Mm-hmm. For example, safety is a great example of a big model calling a small model. So when you get a prompt, it will call a safety guardrail, and it will filter input output. You can imagine something like we just released our vision models a few weeks ago, being able to call a classifier externally, if there's like some CSAM or some other things you want to filter out on the input. Obviously, the model itself has some safety built into it, but if you want to orchestrate that, that's a great use of a small model. And then conversely, you can imagine the big model kind of sitting in kind of the cloud or in some hosted environment off device. And then we've built these like 1 and 3D models, which we released a couple weeks ago, and we thought about the use cases for them. We didn't try and go and make generally helpful models, because it's like you can only make a 1D model so good, right? It's only got so much capacity in terms of like parameters and that. And so when we were thinking about like the post-training data mixture and we did multiple rounds of RLHF and all that, we really aimed it at, I would say, a pretty, I don't want to say narrow, but like a fairly focused set of use cases. So like, for example, like, would you really want to send, to the cloud your prompt rewrite? Like if I want to do prompt rewriting, if my prompt isn't good, or I want to generate multiple prompts, like, is that worth that round trip latency or calling a model that's very expensive? And so when we thought about like those one and 3B models, we thought about prompt rewriting, which isn't truly sexy, but it is a use case, and it's needed. Summarization. So if you can imagine, summarize my last 10 messages, from Messenger or whatever it is, or summarize my last couple of emails, or tell me who sent my last, whatever it is, like being able to do that locally, and be able to do it privately and be able to do it quickly and in a low latency way, I think is important. We also looked at tool use as like one of the key things, because we knew like on-device agentic kind of RAG applications and personal assistance and personal search would be something that makes sense, I think, to kind of host there. And if you wanted, again, do a complex query, you can always send it to, the big Llama model in the cloud, or your, 4.0 or whatever it is that you're using. And so I do think that kind of paradigm, at least in this present day, like does make a lot of sense.
So. And of course, over time, the smaller models are going to get not so small, or at least more powerful. So maybe in a few years, we'll have the equivalent of a 4 or 5B model running on device.
I think I saw a tweet. I'm not on X too much, but I do follow a few folks, and like I think it was Julian and Hugging Face, or might have been Clem, I can't remember, but they were like, hey, by the way, like look at the 1B, it actually eclipses the 13B in performance, the previous like Llama 3.
Yeah, it's crazy.
And it's a great model, and a lot of it was due to the fact that we were able to extract logits out of the 4 or 5B, and we pruned and.
Of course, you need the big model first to train.
Exactly.
And distill to a small model.
Yeah.
So maybe to end, I'm going to ask you to make some predictions.
Oh boy. Okay.
So 5 years from now, where are we going to be? So what are the kind of limits of scaling? That's kind of one aspect. How ubiquitous is AI going to be in our daily lives? In both kind of our interactions, or maybe think about physical devices, and third, are we going to have invented something completely new, like genuinely pushing the frontier of human knowledge in a substantial way?
Yeah. Oh, these are great questions. I think on the architecture and scale, I think it's really interesting. We've been, the attention paper has been out for how many years now? I guess
2017.
So it's been, we're approaching 7 years, I think, or so. I think the transformer is a challenging architecture. Obviously, we've optimized the living, what out of it as a community. It's great for autoregressive like data types, and like in terms of like text and audio. I think it's difficult. Like I think images is kind of an interesting modality, and some of these other modalities are like not really great fits for transformers. I also think that, getting past like the quadratic, like computational, like need for attention is like, it's expensive, right? And we really want to like extend context like this as much as possible, right? Because it's like really useful to do like in context learning and some of these use cases I see where you like ingest this like massive code base. And you know what I mean?
Yeah.
Which is like really cool. And you can take this huge code base and you can use it. And there's a couple of companies that I've chatted with in the past where they have their own proprietary languages. And so having something that they can like just basically train their entire their entire code base on and be able to use as like a co-pilot proprietary within their company is like a really interesting thing. So I'm like hopeful that like we keep pushing in different directions. Like I think this is where like we need academia, we need like industry labs to be more open about these new architectures.
Right.
Because I think I think if the transformer architecture is it, I would be surprised.
I would be surprised too. I mean, it might take a few years, but like in 5 years, I don't know. Let's say in 20 years, if we're still training transformers, I think something would have gone wrong.
I think the second thing I'll say is, I think in a few years, I think we'll start to see, like Gen AI is more of an operating system. And I've said this before in different contexts. And if you kind of like look at Linux, there's a kernel, and there's a few contributors to it. Like I don't know how many people. I was looking at actually their GitHub repo this morning. Linus is still like the top contributor to it, and he's still pushing PRs. And I'm like, okay, amazing. So you can imagine like this operating system that gets kernel updates, and those kernel updates enable new functionality. And maybe in like a couple of years or even a year, I actually don't even care what the kernel is. Like I mean, I hope it's Llama, and I think it will be Llama. But I really, at the end of the day, I'm building an application. I'm building something.
Yeah.
And I'm old enough, I guess. I'll date myself once more here during this talk. But like, I remember when Microsoft, when they showed up at a trade show and they had penguins on their booth, and that was like a big shift, right? When they started like supporting Linux, right?
Yeah.
And I do think like it will become much more of an operating system that that application developers like will keep abstracting to the point where application developers like have a pretty simple way for like kind of I'll call it an interface more generally, but they'll have something that they're building on and they don't really know, because I mean, do you know the Linux internals very well?
No.
Do you care about disk access and like memory and the
I
kernel?
used to have to compile my kernel, but no,
right.
no longer.
I mean, you probably know more than many given your history, but like, but most people don't know the internals of Linux. Yet they build applications that run on Linux because of the ecosystem.
Yeah.
Because clouds have them, support Linux instances, because embedded devices use Linux. It's kind of everywhere. It's kind of like Android is kind of at the end of the day a Linux-based operating
Well, the nice
system.
thing about software is that the abstractions are actually clear. Like one of the challenges with programming with language models is that sort of we're still trying to figure it out. So hopefully that part will mature to the point where language models become, I mean, they're getting much better at this, but they become such a primitive that you would just like, oh, of course you call a language model for this, just like you call a calculator for that.
Yeah, I mean, it kind of, and that has pretty far-reaching implications in that I think we're not going to be judging these things by MMOU in 2 years or whatever.
Yeah.
Or
hopefully,
right?
Hopefully.
I mean, I think we're going to saturate those benchmarks. I think the benchmarks, in my opinion, that are more interesting, obviously, are like LM-sys and how they're trying to build a more human element to things, and that that team has a lot of things. I spent the day on Friday with a lot of the students, and they're working on some pretty cool stuff. I do think like that's more closer to how a human would interact with the technology and how you can kind of judge how well models are performing. So I think like that, we will get to that level, and that'll like that will further bring the community farther away from like the low level tools and all that. I think the third thing I'll say is we talk a lot about agents, and I think agents are going to kind of they're going to slip their way into our daily lives in ways we just don't like think about. Like as a consumer, like the way I kind of look at agents is at least the initial like agents, I think, will do things that we just don't like want to do, like filling out a form.
Yeah.
You know what I mean? Like filling out and like sending it over, or like, or aggregating or like disparate data sources, like asking a question and having it go and pull different data and like summarizing things. Like these are like agentic things that like I don't want to go off and like find 5 travel sites of of information and go make a purchase of a ticket. So I do think like we're just going to start. So applications might start to feel like more seamless or easier.
Yeah.
And I think that's behind the scenes. Like we're all scrambling to figure out like what the paradigm is to do that and get it like scaled, broadly and like build these applications that have product market fit. But I do think like if I put my like consumer hat on it, I do think a lot of this technology is going to start to just feel really natural.
Yeah.
And because these are things that I don't want to spend time on. These are things that I don't care I don't want to go and like I have to like we just finishing a renovation in our house and we have to get insurance on the house. I'm like I don't want to go to like 10 sites and like go find insurance for home insurance for my renovated house. Like, do I have to go to State Farm and whatever? So I think an agent could go and pull that data and help do that for me.
It's almost like you want to autocomplete, not just for text, but for like in actions.
Yeah.
Like anything you're doing, it should just.
It should feel that way. And I think that's kind of where we're going, but they're going to get much more immersive and much more intelligent and much more helpful, I hope. And I think, we're building kind of like the layers and the components that hopefully underpin all of that.
Yeah.
So.
One thing I think would be really cool, but I don't know if anyone's working on it, is having something like a life coach, something that can really, an agent that can really help you kind of set goals and kind of think longer term. Because a lot of, I think, what we experiences that we have is we have a demand, we get it, we get a response in 2 seconds, and then that's it. But now we have the potential of capturing very long context, and what can we do with that? I think that would be really.
My hope is that becomes a very personalized experience and something that's also very private. I mean, you can imagine a model with long context like running very locally to you that maybe is like updating a set of adapter weights in the current paradigm, and so it becomes like it learns and it's doing on-device training, and it's very kind of transparent to you. I think that feels better than having a big cloud model that is that I'm pumping data out to. Like I'd want to. Those interactions like have to be low latency. They have to be personal.
Yeah.
You have to be able to trust them.
Right. The other thing I think is really, and I found really exciting, is that how much you can learn from these language models.
Yep.
Like you have a question, you just go to Llama or Claude or whatever, and you ask a question, and it can explain this. Sometimes I ask, how do you explain to a 5-year-old? Sometimes for me, sometimes for myself, whatever. And it's great. So I think as a kind of educator, I find the education aspects really exciting as well.
Yeah.
Well, great. Thank you so much for that fascinating conversation, and thank you for all your work in open source and AI, and helping the community, giving the community all these tools going forward. So thanks again for joining us, Joe.
Awesome. Thanks for having me. This is awesome. Appreciate it.